Hello, second grade, and welcome back to another week of investigation. This week, we are going to be looking at how liquids change in water. So, as a review of last week's investigation, we looked at how different types of solids change when they are mixed with water. We left them off overnight. We watched those changes happen, and then we took them out of the water, and we saw the other types of changes that happen. And we realized that sometimes changes are reversible, where we can fix them and they can return back to normal. And some changes are irreversible, where they cannot change back to normal with our solids mixed with water. This week, we're going to take a look at how liquids, different types of liquids, change with water. Are they reversible or are they irreversible, like some solids? As you can see, we have some liquids out in front of us right now, and these liquids may look very familiar because we have used them before in our liquids investigation a couple of months ago. So today, we're going to do our mixture with water. We are going to be observing, so make sure you have your notebook or your Google slide ready, and let's begin. Our first liquid that we are going to be working with today is dish soap. So in this bottle we have some dish soap, and I also have some water over here that we are going to be mixing with the dish soap. So I'm going to uncover this. And I want you to think of all the property words that we use to describe the dish soap as it is right now. Remember, property words are describing words. So you can talk about how it moves, how it feels, how it smells, how it looks. And there are also some special liquid property words like transparent, translucent, viscous, and simply it just may have some color in it. So I want you to think of those property words as I'm beginning to mix the water inside. So let's see what happens. Alright, so I'm going to stop there, and this is what the dish soap looks like right now. I just put the water inside. It doesn't look like there's much change. I'm going to put the cover back on and bring it a little closer. So as you can see, we can still see some of the water. There's starting to be some bubbles forming at the top, and also bubbles are one of our liquid words, property words too. I can't see the water as much as I see the dish soap, so it looks like it's changing it a little bit. I wonder what happens when I shake it up. Let me shake it up really good. All right. Wow, what happens when I shake up dish soap with water? As you can see at the top, we have lots and lots of bubbles or foam at the top of our bottle. And then it looks like the dish soap and the water mixed at the bottom, and it still has this orange color. We're going to leave that shaken up, and we're going to put it to the side and move on to our next liquid. Next up, we have syrup. Now, if you remember from our investigation before, syrup is viscous. It moves slowly, slower than all the other liquids. And we are going to put some water inside and see if there's any changes like there was with the dish soap. Hopefully I can get this off. It's very sticky. Okay. All right. Going to put some water inside and watch what happens. So now that the water is inside of the bottle with syrup, we're going to place the cover back on top, and we're going to take a closer look. So as you can see, the water is very light. It's at the top of the bottle, or towards the top. It looks like the syrup is still more towards the bottom. There's some bubbles rising up, but not as much as the dish soap. did. I wonder what happens when we shake it up. Let's shake it up. Do you think it'll have the same changes as the dish soap? Let's see. Oh, all right. You may not be able to see it from so far. I'll bring it a little closer, but inside there are some bubbles floating from the top or the bottom to the top of the bottle. And then there's some bubbles forming at the top layer of the bottle too. Not as much foam as the dish soap, but there are some changes that are happening when the water is mixed with the syrup. Let's see how fast it moves. Does it move any faster than it did before? Yep, a little bit faster since the water is inside. Some changes, not as much as the dish soap, but there are still some. So we can record that in our notebook. And let's move on to the next liquid. Okay, next up we have detergent, laundry detergent. This is what we use to wash our clothes. So inside of this bottle we have a little bit of laundry detergent. It does have some color to it. As you see, it's a light bright blue. Okay, it moves pretty fast in the bottle. Alright, if I move it from side to side, let's see what happens if we put water inside of our detergent bottle. Before I pour it in, do you think it'll have changes like the syrup or changes like the dish soap? Let's see what happens. Okay, so we have our water inside. I'm going to close it back up. Let's take a closer look. So it's a little hard to tell on camera, but at the bottom, the blue is a little bit darker, which shows us that the laundry detergent is still towards the bottom of the bottle and the water is a little bit on the top. Now the water is changing a light blue color, so it looks like the detergent is taking over it just a little bit. But let's see what happens when I shake it up. Alright, I shook it up really good. Oh, and look what happened. Now we have a lot of foam at the top of our bottle, very similar to our dish soap, which is still very foamy at the top here, right? And then there's a mix of the water and other parts of the detergent towards the bottom because it has that bluish color. Very interesting. I wonder why. Why do you think the dish soap and the detergent both turned foamy at the top of the bottle and stayed their color towards the bottom? I wonder if it has to do with any of the properties that the liquids have. I want you to think about that as we move on to our next liquid. The next liquid we're looking at is hand soap. Now, hand soap is something we should all be very familiar with. And before I put the water inside, I want you to think of when you go to the bathroom and then you have to wash your hands, or before you have a snack and you wash your hands with soap. What normally happens when you put that soap into your hand and then wet it under the water? Do you know? I think if you know what happens, you may know what happens next when I place the water inside of this bottle. Let's see. Okay, we're going to close this up and take a closer look. All right, look at that. At the top, I'm already starting to see some bubbles. I think maybe some of you made that guess already. And as you can see, this one is a little more clearer than the other liquids that we worked with. At the bottom, we see the dark pink. That's the hand soap. And then there's another layer here of water that is clearer than the hand soap. It's a much different color. The water is starting to turn a little light pink, but not as much. Let's see what happens when I shake it up. All right, shaking it up really, really good. And ta-da! Did you guess that it will be foamy? Well, if you're really good at washing your hands, then yes, you guessed right. At the top, just like the detergent and just like the dish soap, we have foam at the top, and then we have our colored water mixture towards the bottom. Did you know that all three of these liquids have very similar properties? And they kind of all do the same thing. They clean, right? The detergent cleans our clothes, the hand soap cleans our hands, and the dish soap cleans our dishes. So that may be the reason why all three reacted the same way when we mixed them with water. This will be a very good thing to record in our notebook. So as you record it, we're going to get ready for the last liquid. The very last liquid that we will be working with is oil. Now, oil is much different from all of the other liquids that we've done so far. So before I put in the water, I want you to pause and think. What do you think will happen? Do you think it will be foamy like the soaps? Do you think it'll be bubbly like the syrup? Do you think there'll be no changes at all? Let's see what will happen. I'm going to uncover this, place in our water, and then we're going to take a closer look. I see some things are already starting to happen. Let's take a closer look. Okay, as you can see in the bottle, there are some bubbles forming already inside. That's a big one right there. And it's hard to see on camera, but actually the oil is starting to rise towards the top of the bottle, which is much different than the other liquids which settled on the bottom of the bottle. Think of those properties that oil has that may be the reason why it made such a different change. Now, we're going to put it to the test. Let's shake it up. Shaking it up real good, and there we have it. Okay, it's a little foamy, not as foamy as the other soaps, but yes, it does have some foam at the top here. And then at the bottom, we have an oily water mixture too. It's a light yellow. So it did have some change as it was mixed with water. Let's record that in our notebook. So as you can see, when different types of liquids are mixed with water, depending on their properties, they have different changes that happen. So now that we've recorded all this information down in our Google slide or in our notebook, we are going to add on to this investigation by leaving these bottles overnight to see what changes happen. Do you think some of the liquids will return back to normal? Will there still be a water and liquids mixture? Or will there be a completely new change to these liquids and water mixture? I want you to think of that, and then tomorrow we'll take a closer look.